Hello, my name is Martin Hamburg, and I'm one of the owners of Homewood Home Health. This is the first of a pair of training videos concerning Alzheimer's disease and related disorders of language and memory. In this first one, what I'd like to do is to tell you what's new in the field of Alzheimer's, how we currently understand how Alzheimer's affects the brain. That's a very changing story. In the last 5 years, we've learned a lot of new things which are affecting how we can treat people with Alzheimer's disease, both pharmacologically and also behaviorally. And in the second video, I would like to specifically discuss with you the different types of behaviors that people with Alzheimer's show, or people who are what we might call pre-Alzheimer's. Today, the common term is MCI, mild cognitive impairment, which we now know in about 50% of the people who show MCI that they're going to go on to develop Alzheimer's disease, and how we can become better caregivers and better therapists, helping people with Alzheimer's disease, MCI, using some of that knowledge. One of the things you may ask is why, in fact, don't we just start with that? Why don't we get right busy and talk about what you people can do in your home visits? And I think there are several reasons for that. One, we would like to represent ourselves as being the experts in care, treatment of individuals with Alzheimer's disease and related neurodegenerative disorders. And to do that, all of our staff should be up to date on what is new in this field. Secondly, it's really been a dramatic change. I remember as recently as 20 years ago, that's not that recent, but 20 years ago, I remember when Ronald Reagan first was diagnosed with Alzheimer's disease. And he went on television and he basically said, I know that I have a very serious disorder. It's going to affect me tremendously. I want to tell you all how much I love you, how much I appreciate all you've done for me. And this is going to be my last appearance in public. I'm going to go back to my ranch and I'm going to just wait for whatever fate has in store for me. And I'm going to face it with honor and dignity. Goodbye. That's no longer the way we deal with Alzheimer's care. And I think that you should know about those changes. Also, really, you are very valuable advisors to all your families. Now, clearly, one of the things that you must say and say repeatedly is please go speak to your physician. And he will tell you what's the best course of action for you or your loved one. That's professionally necessary that we do that. But you know what the truth is? Many physicians know less about Alzheimer's disease than you're going to know at the end of watching these two training videos. Still got to come up with that caution. But you're going to be working with families, and you can give them good advice, good information on where they can learn more so that they can have the very latest. And lastly, we now know that Alzheimer's disease actually begins several decades, at least 10 years, 20 years before symptoms develop. And so all of us are a little bit worried about Alzheimer's disease. And now there are things that you can do to reduce the chances that you're going to develop symptomatic Alzheimer's disease. I don't care if you're 60 or if you're 40 or if you're 20. There are things that you should think about to reduce the likelihood that you're going to suffer from this disease in the future. So there's maybe even some personal reasons why you may be interested in a little of this material. One thing before I really start, I want to ask you most sincerely. I'm very anxious to have from you feedback, obviously questions, obviously suggestions, things that I could do better. So please take a moment and write to me. My email address is mhamburg, MHAMBURG, at homewoodhomehealth.com. And I'd very much like to hear from you. Now, I used a big word early on, and that was neurodegenerative. It's a very fancy term that simply means that the brain is degenerating, it's shrinking, it's disappearing in size. Let me give you some numbers. This is something that maybe tonight when you're having dinner with your spouse or your children or some friends, you have some gee whiz facts that you could impress them with. There are 100 billion, that's billion with a B, cells in the brain, of which 5 billion of those are neurons. The other 95 billion are glial cells and blood cells. Vast majority. It's interesting, we know some things about what the glia does, what it's for, but we have a lot yet to learn about those glia cells. There are a whole lot of them. But let's talk about the 5 billion neurons. You're born with most of these, but they do continue to differentiate. They continue to migrate. They continue to grow. They continue to make new connections, all certainly through the first about 20 years of your life. One of the reasons why I think I personally am so worried when I see little kids, 8 and 10 years old, with helmets on and gear and playing tackle football. Traumatic injury is so devastating to anybody, but particularly devastating to children because their brains are still developing. I happen to love football, and I wish it could be that kids started playing football when they got to college. But I know that's never going to happen. They're going to start playing earlier and earlier. But traumatic brain injury of children is devastating because the brain is really still growing and developing until you're 20 years old. After 20, you start losing neurons, and they die at the rate of about 9,000 a day. So if you do the math quickly, you'll see that by the time you get to be 80 years old, you've lost about 200 million neurons. But however, that's still only 4% of the total number of neurons that you have. 96% you still have. Most people are pretty okay. Now, those 96% may not be completely healthy. And one of the things we'll talk a little about is white matter disease and why old people walk so slowly and have so much trouble balance, because those are 96% of your neurons are having some problems, but at least you still have them. They haven't disappeared. Now, with Alzheimer's disease, instead of losing them at the rate of about 9,000 a day, you're losing them at the rate of 100 to 200,000 a day. And even though that may not start when you're 20 years old, if you just lose that number from when you're 60 to when you're 80, you're going to lose basically 1.5 billion of your neurons, or about 32% of what you have. So instead of 4%, you've lost 32%. That's quite devastating to lose that number. So what we have to understand what happens to the brain in people with Alzheimer's disease is you have to remember that the human body is a big protein manufacturing machine. We take in fats and carbohydrates. We mainly use those for energy. But we take in proteins and we break those proteins apart to smaller, simpler components and then recombine them to form everything that we have in our body. Every type of tissue, every type of cell, every type of parts of cells inside are made of proteins. We're a huge protein manufacturing machine. We do that all our lives, not just brain, but every single type of tissue we have. And the proteins that we build are very complex molecules. And they actually, in order to do their work, have to have a certain type of geometric shape. If their shape is wrong, they either can't do their job or they can actually hurt the cells that they're in. They can actually damage and kill the cells that they're in. So we have all sorts of diseases that we refer to as proteopathies, another big word, but it is really protein folding disorders. The protein hasn't folded correctly. It hasn't made the right geometric shape. Alzheimer's is a protein folding disorder. Parkinson's disease, you all know about Parkinson's disease. That's a proteopathy. That's a protein folding disorder. ALS, so-called Lou Gehrig's disease, is a protein folding disorder. Lewy body disease, sometimes called dementia with Lewy bodies, the second most prevalent type of dementia of seniors, is a protein folding disorder. Frontotemporal lobar disease or dementia used to be called Pick's disease. Nowadays, we distinguish three different types of frontotemporal lobar dementia. One of them we still call Pick's disease. The others we have another name for. That is a protein folding disorder. So we've got a lot of these that are very, very related. In the case of Alzheimer's, the protein is called beta amyloid. You've heard of that. And actually, we often talk about beta amyloid 42, which simply refers to a certain type of beta amyloid, certain number of amino acids that make it up. And it's generally written A with a beta, the Greek letter B after it, 42. And so even though we say beta amyloid, we generally say AB42. So somehow we got a lot of AB42 accumulating in the brains of people with Alzheimer's disease. And for the longest of time, we thought that somehow you started making less AB40, that's a good protein, and more AB42 as you got older. Recently, we've learned that's not the case. You make AB42 all your life. The only thing, for most of your life, you're able to clear it. You're able to get rid of it. And somehow something changes and you're not able to get rid of it. You make a little more, but the major thing which causes the accumulation of AB42 is your failure to get rid of it. And the process by which you do that, by the way, I'm not going to go into, but it involves transporting it along the vascular bed over to your liver, and it gets broken down in your liver and then to your kidneys, and it gets filtered out of your blood and into your urine, and out it goes. And that's basically the way you get rid of all sorts of things inside your body that you don't want. But key to it is the initial transport along the vascular bed. And so we find that cerebrovascular health has a lot to do with whether you develop symptomatic Alzheimer's disease or not. We'll talk a little next time about what we might call vascular dementia. Sometimes you've heard of the thing called microinfarct disease, and a lot of people have vascular dementia. And we thought those were two separate tracks. On this side is vascular dementia, on this side is Alzheimer's disease. But we find, in fact, that they are intertwined, that in fact one influences the other. So today, unfortunately, all those things that the doctors used to tell us about, get plenty of exercise, eat low fats, eat plenty of fruits and nuts, keep your cholesterol down. Not only is that good for your heart and good for your cerebrovascular health, but clearly the evidence now is you reduce your likelihood of getting Alzheimer's disease or symptomatic Alzheimer's disease if you do those things. So we have a tremendous amount to educate people about, and some very recent studies down at the University of Alabama with tens of thousands of older people, though some who had basically the Mediterranean type diet and those that didn't, show a significant less development over the course of 10 to 15 years of Alzheimer's disease, of those that ate low-fat diets versus those that did not. But anyway, this beta amyloid, this AB42 accumulates. That's the plaque. You've all heard about the plaque that we find in Alzheimer's. And the plaque is a big, ugly protein molecule that hangs around outside of neurons. It's way too big to get into neurons. And we've wondered for the longest of time, how come it's so toxic to neurons? Why does it do so much damage? And I think Bill Klein up at Northwestern taught us a few years ago that if the beta amyloid plaque is an elephant, it's giving off these little fleas that he calls addles. And those fleas easily get into neurons and they do some devastating things. Several things, which again, I'm too much to go into and I'm not going to do that. But one of the things that you should know, just because it's going to bring you to a point where I think you'll remember, is it attacks what's called the tau protein. I've always thought about the tau protein as biological Duco cement. It holds things together. And not only does it hold things together like the microtubules, remember, microtubules is a wonderful system. It's how the cell transports stuff that it needs from one place to another. Puts it in one end of the tubule, comes out the other end of the tubule. It reminds me of sometimes in a garage or in the drive-up window of a bank or a drugstore, they have this thing, and you put your paper, your prescription or whatever into a little cylinder. You stick it in this tube, it goes sucking up and around and to the other side. They modeled that after the microtubules. That's what a microtubule does. And the tau protein not only sticks pieces of it together, but it actually forms like a lattice work around the microtubule. And just like Duco cement, it hardens and it becomes basically the structure that keeps the microtubule together. When it attacks that tau protein, the microtubules fall apart. Those are the tangles, plaques and tangles of what characterize Alzheimer's disease. And those are pieces of tau protein and pieces of microtubules lying at the bottom of the cell. And once the microtubules fall apart, it's curtains for the cell. It's going to die for certain. And that's kind of what it does. Interestingly enough, it does a couple of other things as well. There's nothing we can do once those adults get in to prevent it from attacking tau, at least not so far, and breaking apart those microtubules. But it affects the synapse, and it affects cellular metabolism and other things. And in those cases, there is something we can do, because we've learned that the more you use your neurons, the more you kind of flush those adults out, and they have to start destroying those things all over again. So the old expression, use it or lose it? We now have some of the physiological basis of that, and we know how extremely important it is to stay mentally active. In fact, Dave Bennett at Rush Institute coined a term which he called cognitive reserve. And he said that basically all of us have a cognitive reserve, and we should enter that period of time when we're most likely to have Alzheimer's disease, that's as we are a senior, with as much cognitive reserve as possible. So you're urged to stay very active mentally, very active socially, and all those things lead to the cognitive reserve. And the more that you do, again, the less likely you'll develop symptomatic Alzheimer's disease. And for people who already have it, our whole program focuses on what we refer to as microenvironments, way in which people can stay active, doing things that they know how to do, intellectually, socially, and these things delay and slow down the development of the disease. So that's all good, but the question obviously is there anything we could do pharmacologically? Is there anything, do we have yet that magic pill? We've been looking for a vaccine for some time, maybe a vaccine that can break up that plaque before it can give off the addles. A couple of good tries, a couple of interesting tries that have been written up in the paper. You might even hear about some of them on television or 60 Minutes. It's been very tough. Many things don't work, and those that work have side effects and other problems that develop that make them not good solutions. So we still don't have that vaccine. We're looking for ways maybe we can block those little addles from getting into your neurons. That would be cool. And so we're looking at addle blockers. Pharmaceutical companies are spending millions and millions of dollars a year trying to find these things. They haven't really found them yet. We do have 5 approved substances out there to help people with Alzheimer's disease. 3 of them are anticholinesterases. That is, they actually work to perpetuate and strengthen basically communication between cholinergic synapses. I've always made the analogy, the anticholinesterases, they're like a whole bunch of guys holding up a boulder on top of their head. And these guys are falling down and dying one at a time. But it makes anticholinesterases make the remaining guys a little stronger for a little longer. But eventually that boulder comes down. So it's just a Band-Aid, but for many patients at a certain point in their Alzheimer's disease, they're helped and their functioning level is improved by taking one of the Aricept or one of the other anticholinesterase drugs. One of them is a anti-glutamate. It's interesting that glutamate is another substance transmitter that helps neurons talk to one another. It's a wonderful substance as long as it stays inside a neuron. But once a neuron dies and that glutamate gets out, it's very toxic to other neurons. So one dies and it kills two more, and those two die and they kill four more, and four kill eight, and you got the picture. So basically we want to keep that glutamate from spilling out, and Namenda is essentially an anti-glutamate. So we have 3 anticholinesterases, 1 anti-glutamate, and the latest is advertised on television all the time is Nemzaric. And it simply is a combination of the two. It has anticholinesterase and it has an anti-glutamate all wrapped up into one. It seems like its biggest advantage is you only have to take 1 pill instead of 2. It's true that the formulation is a little different, and the 3 anticholinesterases all work a little differently. So some people respond better to one, and some people respond better to other. And the doctors will try them in turn until they find one that's best for you. Very little side effects of these medications, so they continue to be used. But we remain trying very much to get a method by which we can really block the addles from getting in and really arrest the progress of Alzheimer's disease. I'm going to check quickly what else I wanted to talk to you about. I think the next time we have a session, the next training session, what I'd like to do particularly is talk a little about some of the other types of proteopathies, not to go into them with the detail that I went into with Alzheimer's disease in terms of the biology, but just so that you understand the different types of symptoms and what makes the needs of those patients different. And still we'll focus on Alzheimer's because it's the big one. It's the one that we run into most of all. And we want to talk most specifically about how you as therapists or you as caregivers can help patients as you see the types of behaviors that they're demonstrating and how to deal with it either in their care or to give effective therapy. So that will be the object of the second video. Again, I encourage you please to send me comments and suggestions. Very much like to receive them. Thank you.